Hello, hello, welcome everybody. I'll give folks a few minutes to trickle in here. See, so this is the Affordable Housing Electrification Training Series. As you can see, we're running 5 sessions every Wednesday between now, September 6th, and October 4th at 11 a.m. to 12:15 p.m. This is being put on by the California Housing Partnership, the Southern California Association of Nonprofit Housing, and the Association for Energy Affordability. Let's see, people are still coming in, it looks like. So what we're going to do is we have a little poll if you want to fill that out. Trying to get a good idea of what the audience looks like today. So yeah, good. We got some answers coming in. I like that. It's like probably most of the folks here are developers or managers of affordable housing. Excellent. We got a lot of government partners and policymakers here as well, which is fantastic. Good to see, some architects, some contractors, and some financiers here. I hope this will be of value to all of you. So it looks like a few people are still coming in, so I'll give that, maybe another minute or so. All right, folks are still answering, still coming in. Welcome everybody. Welcome everybody who just came in. Yeah, wonderful. We got looks like 82 people in here so far. It's a really great turnout. Thank you, everybody. Give it about 15 seconds and we'll close the poll and get started. All right. Oh, more people joining now. Wonderful, wonderful. Welcome. So, all right. That's awesome. Looks like we have a really good mix of people in the audience today. We're going to be talking a lot about electrification technologies, and this should be a good session for y'all. I'm very excited. So, welcome everybody. My name is Ian Sharples. I'm the Sustainable Housing Program Manager at the California Housing Partnership. We're hosting this Affordable Housing Electrification Training Series, along with SCAN, Southern California Association of Nonprofit Housing, and AEA, the Association for Energy Affordability. Like I mentioned, we've got 5 sessions every Wednesday through this month and into next. It's going to be a real good time. Mark out, basically your lunch hour for the next month because we have some really great content coming your way. So today's session is electrification design and technologies. Next week, we'll be discussing the Inflation Reduction Act funding and participation pathways for that. I know a lot of people have been interested in that topic. September 20th, we have operations of all electric housing. September 27th, we have accelerating electrification with solar energy. I know there's been a lot of questions about changes in solar energy, so definitely check that one out. And then we'll be wrapping it up on October 4th with financing and funding the electrification of new and existing affordable housing. So that's also going to be a really good session. You'll learn about different programs and options for funding the wonderful technologies that you're going to hear about today. Before we get started, I'd like to thank our sponsors. We have Wells Fargo Foundation and Energy Efficiency for All, who provided funding to help make this event possible and this series possible. I'd also really want to thank our housing partner, SCAMP, for all the help on the back end and setting up the Zoom and the registration. Thank you again to Jeanette and Danielle especially. You've been a huge help in getting this all set up. And then finally, I want to thank our program partners, without whom none of this would be possible. So I'd like to thank MCE, Build, the Building Initiative for Low Emissions Development Program, Tech Clean California, SOMA, the Solar on Multifamily Affordable Housing, and finally LIWIP, the Low Income Weatherization Program. All of these programs you'll probably hear more about throughout the sessions, but I want to give them a shout out up front today. So what we have today is a really great presentation from Nick Young from AEA. He's an incredibly smart dude with way too many acronyms behind his name for me to announce. Uh, but he's going to be speaking today about the various technologies for electrification. So if you've ever wondered, what's a heat pump? How can you install it in your developments? What sort of washers and dryers might be the best choice of all the various technologies out there? Nick's going to give you some really great guidance, and I hope you enjoy his presentation. So take it away, Nick.
Awesome. Thanks, Ian. Appreciate it very much. Hi, everybody. Like Ian said, my name is Nick Young. I'm a director of zero carbon buildings at the Association for Energy Affordability. And I'm going to be talking about all electric design and technologies, sort of the fundamental components that go into an all electric building and what do you need to keep in mind as you're starting to work with these components in your new buildings and also your existing portfolio. So I want to start with a thank you to MCE. They have supported the development and delivery of this training in particular. So MCE is a not-for-profit public agency started in 2010 to procure power on behalf of retail electric customers in Marin County up here in the Bay Area as an alternative to PG&E. It was actually California's first community choice aggregator, or CCA. And as of 2023, it serves 4 Bay Area counties. It used to be just Marin. Now it's Marin, Napa, Solano, and Contra Costa County. They deliver numerous programs, and we work with them to deliver a lot of these programs, including efficiency, carbon reduction, electrification, energy storage, workforce development, and training, and things like this. And AEA has been working directly with MCE for over 10 years to deliver programs, and this is one of them. A quick little bit about AEA. So AEA is a nonprofit technical services and training organization dedicated to bringing the benefits of clean energy and energy efficiency to low-income communities. We were first started in New York City as an association of weatherization agencies, and weatherization and the upgrading of affordable housing is really at the core of our organization. As you can see, we operate programs, we do research and demonstration projects, we work on policy advocacy, and we do training. You may have interacted with programs that we are involved in some shape or capacity. The SOMA program, the LIWIP program, the BUILD program, we're involved, or in some cases around those programs in various ways, and are deeply involved in building decarbonization of multifamily, particularly affordable, all over the state of California and New York as well. So let's jump right in to the basics of all electric housing. Okay, the key message with all electric housing is that you can do it all with electricity. Everything maybe that you're used to doing with gas or fossil fuels, we can do it with electricity, and we can do it efficiently. So space heating, we can do with electricity. Cooking, we can do with electricity. Water heating, laundry, pool heating, even fireplaces, you can do with electricity without burning anything. So we're going to talk in turn about each of these. I might skip fireplaces because those are not sort of a crucial technology for folks to know about. If you really want to, you can do a little research on your own. There's resources available. If people have questions afterward, I'm happy to point you to those. But we're going to be looking at each of these in turn. But to start, we're gonna dive a little bit into, I would say, the most fundamental technology that you're going to come across over and over and over again. And in fact, it's so fundamental that Ian mentioned it before I even started, and that is heat pumps. You've probably already heard somebody talk to you about heat pumps, and if you haven't, you're going to. And so maybe you know what heat pumps are already. Maybe you have no idea. Maybe you really wish you didn't have to know what heat pumps are. But the reality is you need to know what heat pumps are if you're going to be effective at managing and working with these types of projects. So we're going to talk through what heat pumps are, how they work, and what you need to know. So what is a heat pump? The good news is you already know what a heat pump is, because a heat pump is something that you already interact with on a daily basis. A refrigerator is basically a heat pump. A refrigerator, all it's doing is using refrigerant to move heat from inside the refrigerator to your kitchen, right? So the inside of the refrigerator gets cold and the air around the back or the underside of the refrigerator gets warm. The heat's moved from inside the fridge to outside. Same with a water fountain that dispenses cold water. There is a small heat pump inside that water fountain that actually moves heat from the water to the surrounding air. If you put your hand next to the vent in a water fountain, you'll feel heat coming off of that vent. So water is actually, heat is being moved from the water to the air. Same with an air conditioner. It's moving heat from inside to outside, right? That's the way that we cool things down, right? We can add heat to things. Historically, we've made things warm by burning stuff, right? We'll talk more about how we can make things warm using heat pumps, but we can make things warm by burning stuff. We know that, but how do we make things cold? Like, we need something to absorb that heat. Well, what we do is we actually just move the heat. So we take heat from over here and we move it over there. That's what an air conditioner does. It takes heat inside and dumps it outside. We can do that with water heating. We could take heat from the surrounding air and we could put it into a water tank. And that's all that we're doing with a heat pump water heater. So a heat pump, very simply, the next time this comes up at a family dinner or at a social event, because you're so excited about heat pumps, you can tell someone that a heat pump is a device that moves heat from one place to another using refrigerant, just like an air conditioner or refrigerator. It's that simple. So what's so great about heat pumps? A few things. They're 3 times more efficient than electric resistance heating systems. They can deliver heating and cooling in a single system. There are a wide variety of form factors for all project types. So any type of building, any layout, you can get a system that will be well suited to that application. And they operate efficiently in all climate zones. Super cold, super hot, everything in between. There's something that will work for that space. So let's now talk about some specific systems around our building. And we'll start with space heating. So when we move from fossil fuels to all electric, and we talk about space heating, a lot of people's first question is, why don't we just use electric heat, right? We can just heat with electricity. So there are a few reasons. First of all, electric resistance heating is 3 times less efficient than a heat pump, right? We have electric heat in a lot of existing buildings, right? There's a lot of electric resistance heaters that you might have in existing buildings, sort of up and down California. But there's a reason that it's not very common in existing buildings in new construction, and in general is not recommended in new construction. You're also going to have much higher heating bills than if you use a heat pump. You're going to incur considerable Title 24 or your energy code compliance penalty. You may not be able to comply at all anymore if you go with electric heat. Folks who've been building affordable housing or multifamily housing for many, many years in California will probably tell you that 10, 20 years ago, it was very easy to comply with electric heat. And now it's very difficult to comply. And you may not even be able to comply with electric heat. It's getting harder and harder. Also, if you're going to have a very inefficient heating system like electric heat, you need to have really excellent building envelopes. So your insulation, your windows need to be really good. Your ventilation system should be really good, so you're not just dumping all of that very inefficiently generated heat out of the building when you ventilate. And you're going to require a separate cooling system. So for all of these reasons, we really don't want to use electric resistance heating. So instead, what are we going to use in an all-electric building to heat? Everyone knows the answer, right? Heat pumps. We're going to use heat pumps. That's going to be the answer to basically every question in this training is heat pumps. So let's talk about individual heat pumps for individual apartments. We're talking about apartments here. There are a few different form factors that you will come across. Starting from the left-hand side, a ducted heat pump. This is most similar to your single family home residential air conditioner. You have a sort of square form factor outdoor unit with the fan blows up. you have an air handling unit inside, again, with the fan blowing up, and then distribution through ductwork, and a return that's usually low on the ground or near the ground. That can be a heat pump that does both heating and cooling. It looks just like a regular traditional air conditioner, but it can be a heat pump, and they can be very efficient. Another type is what's often referred to as a mini split heat pump. So a few sort of terminology things. Why is it called a mini split? Well, if you look at this component, this is the outdoor unit, right? This is the outdoor unit here. This is the outdoor unit here. This outdoor unit is very small. That's where the mini part comes from. The split part comes from the fact that there's an outdoor unit and an indoor unit. This one also has an outdoor unit and an indoor unit. So you could call this a split heat pump. We usually just call it a ducted heat pump. But this one, it's called a mini split because the outdoor unit is small, it's skinnier, and usually the fan blows horizontally, and it's split. You have an outdoor unit and an indoor unit. So a mini split heat pump can be either ducted or ductless. So if you have this thing outside, you could have this kind of ductless indoor unit, and you may have a few of them, or you could have a ducted indoor unit. You may also have seen this kind of indoor unit. There are a variety of different form factors. And these are all great options, and just one thing that you'll see. Another option that you may come across on projects, particularly in new construction these days, is something called a vertical terminal heat pump. So this is like something in between a package terminal heat pump, or PTAC, which folks have probably heard of, and a ducted heat pump. So it is attached to an exterior wall, very similar to a package terminal heat pump, but it has ductwork that generally goes up and then sometimes can go over to the side and maybe to an adjacent bedroom or two. These are moderately efficient. They're not great, but they work, and they're about as efficient as a package terminal heat pump, but they can be relatively low cost. So these are an option that we're starting to see folks go with. So a vertical terminal heat pump. They have to go on an exterior wall though. And then we have package terminal heat pumps, or PTHPs. So, you're starting to see some of these slimmer form factors, sometimes referred to as room heat pumps. You may have heard of a company called Apoca or Innova. That it's an Italian company that has a very well-known unit with this kind of form factor. They can be very efficient. These are great for single room applications or smaller apartments. So this is just a few of the different form factors that you'll find. So very large apartments, lots of bedrooms, smaller apartments, studios, everything in between. There are systems and form factors that can work to do for heat pumps, for heating. And remember, with a heat pump, you also get cooling. You're getting heating and cooling in a single system. You don't need a heater and an air conditioner. It's all in one thing. Oh, by the way, Ian or other SCAMP folks or CHPC folks on the call, if there are questions that pop up in the Q&A, feel free to unmute yourselves and jump in if there's a clarifying question that comes up while I'm talking. I may not be able to monitor the Q&A while I'm going, but you all should feel free to jump in while I'm going. So moving on to central systems. So for your common areas or larger buildings, if you have central systems, you might see things like variable refrigerant flow. You could think of this like a very large outdoor unit with lots of indoor units for a sort of big mini split system. So whereas your individual mini split system, over here you have one outdoor unit with maybe like 2 or 3 indoor units. A variable refrigerant flow system will have one outdoor unit and maybe like 20 or 30 indoor units. So you could serve like a whole bunch of offices. You can serve a whole bunch of apartments with these too. Then you get into sort of energy metering questions with the apartments. But that is an option, and you have less outdoor equipment. There are also packaged rooftop heat pump units for common area or community rooms, things like that, or hallways, as well as things called heat recovery chillers. So you can do 4-pipe hot water and chilled water systems with heat pumps. So if you have buildings with like a hot water loop and a chilled water loop for heating and cooling, you can do that with a heat pump. You don't need the sort of boiler boiler chiller combo, you can do all of it with a heat recovery chiller, sort of get it all in one system. So that's the basics of heating and cooling. So the key takeaways that I'd like everyone to remember for space heating is that it's going to be some kind of heat pump. You're going to get heating and cooling in a single system. And ultimately with heat pumps, something has to go outside. So you need to plan for that. There are lots of different form factors, as we saw. So ask your team, and this is really important, ask your design team for options beyond what was done on the last project. Because you may have just seen like one system type, and there may be others that might actually be a better fit for the particular project that you're looking at. And so a lot of times we see, so I work doing technical assistance for the BUILD program, the all electric new affordable housing electrification technical assistance and incentive program funded through the California Energy Commission. And we see a lot of projects come through where, we are really just spending time like talking through with project teams different options that they have for HVAC systems that maybe they just didn't ask the MEP engineer to give them a few different options for heating and cooling. They're just like, well, let's just do what we did last time. That worked. We'll just do the same thing. So I would say ask for options, see what's out there, because the market is evolving relatively quickly. Another thing to ask for and to look for when you're specifying systems is variable speed equipment or inverter driven equipment. That's going to be the most efficient, and it's going to be quieter because it's going to be able to sort of ride the demand that's coming from the building, as opposed to sort of turning on at max capacity and then turning off, turning on and turning off. Equipment that can vary its capacity and run at like 30 or 40% capacity will be able to run very efficiently for longer periods of time, which is better for your equipment in the long term. You'll have lower maintenance, longer equipment life, things like that. So recommend variable speed equipment when you can get it. Let's see. I'm going to go over the Q&A while we're here.
Yeah, we've got a couple of questions about heat.
Yeah, is the pack? So I see a few. The first one, we'll get to appliances later. There's a question: is the packaged rooftop unit of a larger version of a ducted heat pump? Kind of, not really. So the packaged rooftop unit is the heat pump version of a rooftop package unit. So a rooftop package unit is by far the most common commercial heating and cooling system in the country. And you see it on top of like every Best Buy and every Target and every big box store like ever. And there are some of those in multifamily buildings. And so usually those are an air conditioner with a gas heater, and you can just do that with a heat pump. So they sometimes are slightly larger form factor than the gas version, because the heat pump does need to be able to absorb heat from the air in order to do the heating, as opposed to just like pumping gas into a furnace to deliver heating. It's having to like actually pull that heat from the ambient air on the roof. So sometimes the form factor of a rooftop heat pump package unit is slightly larger than a rooftop gas fired package unit, but it's a little bit of a different system than the ducted heat pump. But usually those package units are ducted. The next question, what are the cooling benefits of a heat pump? What are the parameters within which a heat pump can provide beneficial heating and cooling specific units that don't currently have cooling? I mean, the cooling benefits of a heat pump are that every heat pump can heat and cool. For every piece of space conditioning equipment that you get that is a heat pump can do heating and cooling. And so, especially for apartments that are being renovated and don't currently have cooling, being able to provide cooling, even if it's only a little bit of cooling, is a huge benefit, right? Like heat waves are not going away, and they are not getting less severe. If anything, they are getting more frequent and more severe. And so, to the extent that as we retrofit affordable housing, we can provide cooling for folks while also decarbonizing, like that's a huge benefit for people. So, that really shouldn't be understated. Um,
We do have one other question. David wanted to know, are mini splits used with VRF?
um, mini splits and VRF are sort of two sides of the same type of system. VRF is just like a very large mini split system.
Thank you. I think that's all we had on the heat pump so far.
Yeah. Okay, cool. Let's keep on rolling. And let's move on into water heating. So for water heating, for many years, when we were doing water heating with gas, the idea was we've been moving toward tankless gas water heating, right? That's what it's like, less and less storage, just tankless, tankless, tankless. So if we are moving to all electric, can we just use tankless electric water heaters, right? Maybe we could do that. That would be simple, right? Unfortunately, we can't. You can't even comply with Title 24 if you use tankless electric water heaters extensively on a project for a few reasons. It would require significantly larger electrical service to serve an entire apartment and especially an entire building with a tankless electric water heater. Um, Really, the only viable application for a tankless electric water heater that's sort of heating water up instantaneously with electricity is something like a common area sink with very low utilization, right? That's a reasonable application for a tankless electric water heater. Maybe it's very far from the regular hot water distribution, and people don't use that sink very often anyway, and they wash their hands for like 20 seconds and then that's it, right? Do you need a hot water loop that's staying hot all the time going to that sink? Like, maybe not. It would probably be better just to have one of these relatively inefficient water heaters that's just sitting there most of the time not being used, and when somebody does want hot water for 10 seconds, it turns on and then it turns off. That would be a great use. For really any other usage, you're like not even going to be able to get Title 24 compliance documents that say that you pass code if you try to go with tankless electric water heaters. Much less would you be able to like fit your electrical service in your electrical room for the amount of electricity you would need in your building to be able to do this for like a whole apartment or a whole building. It just like would blow up the size of your electrical panel. So, so what do we think the answer is? How are we going to heat water with electricity if we can't do electric resistance water heating? Heat pumps, you're right. Same answer as for heating and cooling. We're going to use heat pumps. So we're starting to see a trend here. So we're going to be talking quite a bit now about heat pump water heaters. So how do they work? Just like any heat pump, a heat pump water heater uses refrigerant to move heat. And in this case, it's moving heat from the air into the water. So what the heat pump's doing is it's going to be taking in ambient air, and it's going to be using refrigerant to suck the heat out of that air and move that heat into the water. So the air is going to get cold, so it's going to output cold air, and then the water is going to get hot. So what you get out of a heat pump water heater is hot water and cold air. So that's really important to know, that heat pump water heaters generate hot water, obviously, because you want hot water, that's the whole point, but they also generate cold air. So you have to know, what are we doing with that cold air? Where is it going? And where is my heat pump water heater? Okay, cool. So now let's look at some different form factors of heat pump water heaters, starting with unitary systems. Unitary meaning one per apartment. So there are two basic system types for unitary heat pump water heaters. There's split type, where you have a heat pump and you have a storage tank. This tends to be, this type is very efficient. It also tends to be a little bit more expensive than the combined type, where the heat pump and the tank are all one piece of equipment. Also, the equipment on the left, the split type, there's really only one manufacturer, and it uses CO2 as a refrigerant. It's super efficient, works great down to very cold temperatures. It's just really like first cost is the reason that those aren't as common in individual apartment installations as the ones on the right. Also, you have to figure out where you're going to put the outdoor unit. The ones on the right, you sort of have the heat pump on top and the storage tank below. And it's all self-contained, and it looks very much just like a water heater. It's a cylindrical tank with some connections. It's a water heater, right? But it's a heat pump water heater. But keep in mind, this is a heat pump. Each of these is a heat pump. So what's going to come out of this? Cold air. So we have to think about what we're doing with that cold air. So this is a heat pump water heater. Usually, where do we put water heaters? Shove it in a closet. Close the closet, close the door, get it as far away. I want to see it. I don't ever want to see it. I don't want to know where it is. Nobody wants to look at it. It's ugly. Get it out of here, right? Well, we need to be thoughtful about where we put heat pump water heaters. So the key thing that I would just like to impress to this group is wherever you put a heat pump water heater, please get the cold air out of the closet. There are a few ways to do this. Ducting the outlet air, so the air that comes out of that heat pump water heater can be ducted. The best way to get that air out of that closet is to actually put a very small duct straight out of the closet. Then you're good. Because if you don't and you just put it in a closet, you're going to turn that closet into a meat locker. And you have a few problems with that. When your closet is a meat locker, one, you could get condensation on the inside of your building, which you don't want. Your heat pump's going to run less efficiently because now all of a sudden you have a hot water tank in a very cold environment. Your heat pump may not run in heat pump mode at all because some heat pumps only run in heat pump mode, at or above a certain temperature. It's just a bad situation when the location of your, particularly that tank type heat pump water heater, gets too cold. So you really need to figure out how you're going to get that cold air out of the closet. So best way is to duct it out. You could also have a fully louvered door. So we're talking like the whole door is louvers, like the whole thing, top to bottom. You will see manufacturers tell you that like small louvers, high and low, like we're used to doing with gas water heaters, like, oh, a little louver up here, a little louver down there. They'll tell you that's okay. I do not recommend it. We do not recommend it to anyone. They will tell you you can do it. I do not recommend it. Fully louvered door or duct the cold air out. That is my recommendation. You don't need to necessarily duct it all the way outside. These aren't generating so much cold air that if you dump it into the apartment, you're going to make the whole apartment freezing cold. It's not that insane. In fact, there have been studies that show that it has sort of no real noticeable impact on heating or cooling loads inside of the apartment. There's like a slight cooling benefit to having a heat pump water heater inside, but it's not really a huge noticeable impact. You just want to get the cold air out of the closet. That's the main thing. So just get it out of the closet and you're okay. So other things to be aware of. If you put it in an interior closet inside of an apartment, be aware of sound, right? Heat pumps have compressors, they have fans, they have sound ratings, and you can get quieter units, but they're not silent. So be aware of where you're putting it. I would say putting it near a common corridor wall or near a kitchen is probably a better location. Putting it closer to bedrooms is not as good of a location, right? Think about sound and vibration transfer and how close is that heat pump to where people might want it to be quiet. So be aware of that. If you put it at a unit exterior closet, this is something we see a lot in designs, like in a garage or like right off of a balcony, that can be fine, but how cold do the winters get, right? Will the closet, especially if that heat pump is just dumping the air into the closet, like if you louver the door, will the closet get so cold that the water heater goes into electric resistance mode a lot in the winter, right? How are you dealing with the cold air and how cold does it get outside? So like that's something to really keep in mind. I would say kind of the best approach is to put it inside somewhere inside the thermal envelope and but get the cold air out of the closet. Because then it's always going to be operating in heat pump mode efficiently. because it's not going to be outside where it gets super cold. And then if you can get the cold air out of the closet, you'll be okay. If you have it on a common corridor closet, this is an interesting approach that we're starting to see some projects take. Actually, a number in Southern California where they're putting them sort of in closets that are adjacent to the unit, but open to a common corridor. And so they can be accessed by maintenance from the common corridor, but then they're plumbed into the apartment. So you have more doors in the hallway. There could be that could be an aesthetic challenge. As the owner, maybe that's important, maybe it's not. But we're seeing that as an approach that some owners and developers are starting to take for these individual heat pump water heaters. So what do these look like installed? On the left, these two photos are the split type, where you have the outdoor unit and you have the tank. Pretty simple. On the right, you have two of those tank type units where you have the heat pump on top and then the tank sort of attached below it. And you can see the one on the left, this one, both the inlet and the outlet air are ducted. That you can do. And over here, just the outlet air is ducted. Both are options. You can't have too long of duct runs though. So, these are all considerations that you have to keep in mind. All right, so that was individual heat pump water heating. Now let's talk about central heat pump water heaters. So we have larger buildings on tighter sites. We may end up wanting to go with central water heating, and we can do that with heat pumps. So what does a central heat pump water heating system look like, and what does that mean? So the general idea with central heat pump water heating is that you're going to have some sort of heat pump water heater outside, generally, and some sort of storage tank. It's usually going to be pretty big inside. This is the general best practice. Can you put all of it outside? I know y'all are in Southern California. I'm personally located in Oakland. In Southern California, you love putting everything outside. Just put it all on the roof, just put it all outside, that's fine. You can do that. Equipment will last longer if you don't put it all outside, if you put it in some sort of an enclosure. So we recommend the heat pump needs to go outside because it needs to exchange heat with the outside air. But everything else should go inside if you can. So this is sort of a simple, smaller system. If you have a larger building, more units, more heat pumps, more storage tanks, you can grow the system as large as you need to for your building. So you could have multiple heat pumps, multiple storage tanks, but these storage tanks in general are going to be large. They're going to be larger maybe than you're used to seeing for a particular size building. And that's what has to do with the way that we pay for electricity. We pay for electricity both in terms of how much electricity we use, but also in terms of how much we use at any one moment, right? We pay demand charges. Whereas with gas, all that the utility cares about is just how much gas we used over the course of the month. With electricity, you get charged for how much electricity you use over the course of a month, but also how much electricity you used within any 1 minute or instantaneous period over the whole month. That's your demand charge. And so if you have a spike where all of a sudden your building demands a ton of electricity, your bill can be very high for that demand charge. So with anything with electric systems, it's beneficial to design your system to be able to run at a lower capacity for a longer period of time, as opposed to a higher capacity for a very short period of time, right? Tankless systems sort of turn all the way on for a minute and then turn all the way off. That's a recipe for very high demand charges for electricity. So instead, with heat pump water heaters, we design very large storage tanks. So we have a big thermal battery. And then we have these very efficient heat pumps over here that can just simmer for many hours and slowly recharge that storage system, either overnight when electricity is less expensive, or maybe during the day when there's a lot of solar on the grid or solar coming from the building. So the heat pumps are really there to recharge the storage tank, and the storage is there to meet your demand. In terms of equipment options, there are a lot. There didn't used to be a lot of options for central heat pump water heating. The market has really responded to the growth in demand for all electric building equipment. Not all of the things you see on this screen are necessarily purchasable at this exact moment, but most of it is. And I've seen with my own eyeballs most of the things that you see on this slide. And everything here is a real product that either is or will be available on the market very soon, in a variety of form factors, a variety of sizes. So talk to your engineer, and whatever they recommend, I would suggest ask for an alternate. Say, great, thank you for recommending that. Please also give us one alternative so that we know that you're not just getting whatever the rep told you blindly, but that you are using your engineering judgment to make an informed choice. I have a sneaking suspicion that there are a lot of folks who are asked to design an all-electric water heating system for the first time, and they just go to their water heater rep and they ask for what they've got, and they get a system recommended, and then that's what they put in the design. And so I think it behooves you all as developers to say, thank you, design engineer, for this recommendation. Please provide one alternate design, like one alternate manufacturer, so that we can at least have a comparison. So that would be my strong recommendation to everybody, because there are a lot of differences between even sort of the basic parameters of how some of these systems operate. I mean, just looking at this slide, there are 3 different, maybe 4 different refrigerants that you could use in these systems. They're very different sizes. The controls are different. The companies are all different. The piping may be different. And so asking your design team for multiple options, also because the first option that they give you may be very cost effective, but it might be that an option that they hadn't looked into might be cheaper. So it's worth asking for options. Show some examples of some installed central heat pump water heating systems. This is a dormitory at UC San Francisco. This is actually a pretty old system at this point. This was one of the first central CO2 heat pump water heating systems in Sunnyvale. This is a retrofit system. And this is a property in East Palo Alto that retrofitted 2 buildings and built 2 new buildings, all with the same large capacity CO2 central heat pump water heating system. And we've got some other systems in this property in San Francisco as well. So this was a retrofit of an existing affordable property. So some key takeaways for central heat pump water heating. Large storage tanks are going to make your system more efficient. In terms of location of your equipment, it's best to locate the heat pumps outside and the storage tanks and other components inside. Heat pumps are going to make some noise, like any other mechanical equipment. So it's best to put it on the roof and away from apartment units. You can install heat pumps in a garage, but what do heat pumps generate? Cold air, right? So your garage is going to get cold. So just be aware of that. There are also factory-built skids as well as site-built options for really any size building. So talk to your engineer about that and ask, like, hey, is there a skid option for this that could maybe reduce our site labor costs? If it comes factory-built, maybe the material costs are higher, but our site labor costs are lower, and maybe one ends up penciling better than the other. So it's worth asking those questions. All right, I'm going to pause and check the Q&A. Let's see.
Got
Yeah, I'm looking through the Q&A. I see one. Can you put heat pump water heaters in a garage without a closet? I'm not. I mean, you can basically with a heat. If this is about a residential heat pump water heater, which it probably is, because the question was asked like 10 minutes ago, you could put a residential size heat pump water heater in a garage without a closet, no problem. Um, the problem with those units arises when you put them in a very small space with little to no ventilation. And the answer is not put in a fan, because that is just more energy that you're using to correct the problem that we created by like putting it in the wrong kind of location. So I've seen over-engineered solutions where we put a heat pump in the wrong place and we add more fans because we put the heat pump in the wrong place. Like, we should just put the heat pump in the right place, which is a place that has ventilation. A sort of standard residential size heat pump water heater in a garage can work. Garages can still get pretty cold. They usually are not as cold as outside. But that can work. But again, in your climate, if it's in LA, you're probably okay. If it's in Tahoe, that garage is going to get pretty cold. You might want to think about a different solution. So that would be my answer to that one. The next question: do you recommend water softeners to extend the life of a central heat pump water heater and the associated plumbing runs? It really depends on the water quality in your particular area. So you should talk to the heat pump manufacturer, and also make sure your engineer is looking at the water quality reports for the location where you're building. All of this equipment is going to have requirements for water quality and recommendations around that. And so, it's just about making sure that you're operating within those parameters. So it's going to be different for every location. A question: what is a factory built skid? So I see Annette clarifying that it was residential. Great. A factory built skid is basically where in a factory, they take the heat pumps and they mount them on a platform, and then they stick the tanks here, and then they put your recirculation pump here, and they put all your controls and your wiring, and they connect and pipe everything together, and they basically pre-build everything, and then it can just get craned onto your roof, and then all the contractor has to do is connect your electrical, your hot water, cold water, recirculation, and then fill it up with water and turn it on. And so in theory, your on-site labor costs for a factory-built skid system could be much lower. Now you have more off-site costs, right? As opposed to site built. It's sort of like the idea with like modular construction. You like build the apartment off site and then you just plop it down on site. It's kind of the same thing for a plumbing plant or hot water plant. You can do the same thing. So that's the idea. Can you expand on resistance mode? I am not going to talk about that much more later. Resistance mode is basically most residential heat pump water heaters. Let me go back to that slide. Most residential heat pump water heaters, and I can talk about this for like a second, then we need to move on. Most residential heat pump water heaters have, well, actually, these units over here, these all have both a heat pump and they have an electric resistance element in them. So they're often referred to as hybrid heat pump water heaters. This one over here has no electric resistance. So this is a CO2 heat pump. It operates at full capacity all the way down to like 15 degrees Fahrenheit. And it continues to operate at like reduced capacity down to like minus 15. So this one has no electric resistance. It's just a CO2 heat pump here and a storage tank here, and it's just water pipes in between. So if you're concerned about efficiency, this one is basically always going to be the most efficient, but it's also usually the most expensive in terms of installation. These are much less expensive to install, terms of equipment cost. You also don't have to locate a tank and an outdoor unit. It's just one piece of equipment. But the refrigerant they use sort of operates decently well down to about 40, maybe 36 or 8 degrees. And then below that, it can't really keep up. And so they have electric resistance elements in them. That's just electric resistance heating. The, 3 times the energy of the heat pump, much less efficient. And so if the closet that this is in, and this thing is pumping out cold air, right? So even if outside it's like 48 degrees, this thing is pumping out like 30, 35 degree air. And so it's going to cool down the closet that it's in. So it might generate much colder ambient conditions for itself that then cause it to go into resistance mode, spike the electrical usage of the equipment if you don't deal with the cold air that's coming out of the heat pump. So that's the idea. Is there are also things you can do with like what settings you use. Do you put it in heat pump mode or hybrid mode or efficiency mode? Do you use a mixing valve? There's all kinds of things around that get sort of very technical and in the weeds. I just wanted to sort of mention that for you all, I would say the most important thing is getting the cold air out of the closet. That's like the main concern when you're looking at a project design, is to ask like, hey, design team, hey, mechanical plumbing engineer, hey, architect, how are y'all getting the cold air out of this closet? Because you are all now well-informed developers. You know that heat pumps generate cold air. And so you know to ask, where's the cold air going? And if they just say, it's going in the closet, you can say, no, thank you. I would like this cold air to please be gotten out of the closet somehow. And you can have that conversation. And a last question, does a skid eliminate the need to house the central water heater inside? It can, yeah. There are some skid systems that are entirely enclosed in like an enclosure. And so you can just like drop the fully enclosed box on the roof and you don't even have to build a mechanical room. So that can be. I am going to pause on the Q&A and continue on to the next section. So let's go. Okay, so we've talked about water heating, we've talked about space conditioning, let's talk about renewables. So we're gonna have a whole thing about renewables in a few weeks, but I'm gonna just speak quickly about sort of the trade-offs, at least in terms of sort of building systems, not necessarily in terms of rates and all of that. Like that's a whole separate conversation that is changing rapidly. But just in terms of like how systems interact, sort of PV versus thermal. For a whole host of reasons, PV is a better fit for an all-electric building than solar thermal is. I'm not going to go into a ton of detail on this. We have a whole thing on solar, and I want to get to the rest of the content and also have time for Q&A at the end. So just the main takeaway here is that if you're looking at solar PV versus thermal, you're generally we're going to be moving away from solar thermal towards solar PV. Now, if solar PV rates go into the garbage can, which it seems like there is some chance that that may happen, then maybe solar PV becomes less of a good idea than it used to be. And so maybe this equation changes, but currently this is sort of where we're at. Okay, let's talk about cooking. For electric cooking, there are really 3 types. There is induction, there is radiant electric, which looks from the outside very similar to induction. And then there is electric resistance, which we've all had and virtually no one likes. We are going to focus on induction because it is the least understood and most excellently awesome kind of electric cooking. So what is so great about induction cooking? A few things. One, it is the safest cooktop you can have in your building because it heats the pan, not the cooktop. If you turn on an induction cooktop and there's no pan there, nothing happens. It beeps at you because it doesn't detect a pan. Nothing gets hot. It is impossible to have a hot stove with nothing on it with induction. Also, if you have a hot stove and you take the thing off, nothing is hot. Like there's no the stove isn't hot. It's the pan that gets hot, right? The stove will only be hot because the hot pan was sitting on it, right? Getting the pan is actually what gets the stove hot, not the other way around. Um, they have features, and most of them do, such that if a pan, like let's say, boils over and somebody leaves it unattended, and the pan just gets hotter and hotter and hotter, it actually will detect that there must not be anything in this pan because it's just getting insanely hot, and it will turn off. Even very cheap induction has this feature. So safety is a huge benefit of induction cooking. There's also, by the way, there's no fire, but that's not really induction versus regular electric, because regular electric doesn't have fire either. It's also the fastest cooktop. It's faster than gas or electric resistance. It boils water in half the time of any other type of cooktop. It has extremely precise heat control. You have less waste heat, so you have less overheating of your kitchen. It's much more comfortable to cook in a kitchen with induction. Induction cooking. And there's lots of cookware and cheap adapters for using induction. And you may be saying, yeah, that's great, Nick. But what about equipment cost? Induction's expensive, right? It is currently not the cheapest electric range. It probably will never be the cheapest electric range. But hopefully prices will come down as adoption accelerates and manufacturers see that there is real demand for high quality, affordable induction cooking options. So this option that I found was from like 3 days ago, Home Depot, just over $1,000. You buy in volume, you probably can get a better price than that. Compatible cookware. So pots and pans do need to be ferromagnetic, meaning a magnet needs to be able to stick to it. But there are lots of affordable options. You can also get an adapter that can basically make any pan work for less than 20 bucks. So, if you think about the total cost of an apartment, like what's an extra 80 bucks to just buy people a cookware set to be able to enable residents to cook with the sort of far and away best cooking equipment that exists and also the safest cooking equipment that exists, right? To me, that seems worth it. What if you have commercial spaces in your building and they're all electric? Is there all electric commercial kitchen equipment? Yes, there is. And in Southern California, you have the SoCal Edison Food Service Technology Center at your disposal to offer assistance to any commercial tenants that are looking for help in designing an all-electric kitchen. They have all sorts of services, rebates, education, training, things like that. So encourage folks to direct any commercial tenants there. What about for laundry? We're really only talking about dryers. Washers are already all electric. They just spin your clothes around with water. For clothes dryers, there are residential heat pump dryers, there are electric resistance dryers, there are combo resistance dryers, washer dryers. All of these can be done. Heat pump dryers have gotten a bad rap. Some of it's justified, some of it's not. I'm just going to say there are options. You can sort of make the decisions that are right for your project. I don't have strong takes on clothes drying. Commercial clothes drying, I do have strong take on though, which is I feel very frustrated that Europe and Asia get to have electric heat pump commercial dryers and we don't in America, because we don't get to have nice things in America because manufacturers choose not to bring their nice products to America for some reason. So we still have to use electric resistance commercial dryers. Literally the same company, Speed Queen, that makes like half of the commercial dryers that are in these buildings, they make a commercial heat pump dryer, but they won't bring it to the US because they don't think we want it. So maybe ask Speed Queen next time you talk to somebody. All right, some other systems that you'll see in an all-electric building, or that you may be thinking about, like, well, what about that thing? How do we do that with electricity? What about heat pumps for pools and spas? I'm just going to say, yes, you can do it. There are pool and spa heaters that use heat pumps. You can heat a pool and a spa with electricity very efficiently with a heat pump. I'm not going to go into more detail on that. I don't know how much new affordable housing is really being built with pools and spas. Probably there are existing properties with pools and spas. If you're electrifying your existing portfolio, you may be looking at heat pump, pool, and spa heaters. There are options out there for you. Programs will help support the electrification of your pool equipment. EV charging, right? EV prices are coming down. with incentives, including for used EVs. There are, through the Inflation Reduction Act, there are incentives for used EVs, which is really exciting because that's going to help EVs be accessible to more people. And also, EVs are more affordable to own and maintain long term than gas cars. So they really are a more affordable car than gas cars are. So low-income residents should have access to charging. Like, that is the equitable thing for us to provide to low-income residents because it's a more affordable solution for a personal vehicle. There is charging equipment available with third-party management. There are a number of different companies that you can contract with. And I would just say for new build projects or major retrofits, plan ahead. Plan for future charging. There's some requirements that you have to have a certain amount of charging capacity, but sort of plan for even more. Think about, what the landscape's going to look like in 10 or 15 years when you're no longer even going to be able to buy a gas car. What are residents going to be driving, and how much charging are people going to want then? And can you plan for that future as opposed to today? There's also battery storage. It is a prescriptive requirement for new multifamily buildings along with solar PV. Battery storage can improve resiliency in your building by powering critical systems during a power outage, which unfortunately are happening more frequently. They can also help reduce peak electrical charges, which can really help. And really, I would say all new projects should be built at least storage ready for future battery installation. And if you're doing a rehab, thinking about, even if you're not installing a battery, if you're doing any electrical work at all, thinking about planning for future storage installation could be really valuable. And this gets into just the general idea for your electrical infrastructure on these projects is you need to plan ahead. All electric buildings eliminate gas costs, which is great, right? Any gas main extensions, gas meters, interconnection fees, in-building infrastructure, all that stuff goes away. But with all of our systems powered by electricity, projects may need a larger electrical service or electrical panels. Not always. I've seen projects that switch from mixed fuel, so gas and electricity, to all electric, and the electrical service for the building didn't change. I've seen other projects where it did change, so it depends. Either way, you should consult with your electrical engineer early on to ensure they know that the project is going to be all electric, and start talking to your electrical utility as soon as possible, because that dance can take a while and can get complicated. So plan ahead. In conclusion, all electric equipment may look a little different and need different space allocation in an all electric building than what we used to do in the past with fossil fuels, but that's okay. Things change. We don't ride horse and buggies anymore, but we like that there's not horse poop all over the ground. So that's great. Heat pumps are your new best friends. They're going to be everywhere in your new buildings. They're going to be everywhere in your existing buildings that are retrofitted. So get used to them. There are lots of options for every application, and the market is evolving quickly. So I really just encourage everyone to keep in mind that what you did on your last project may no longer be best practice. So keep asking questions, keep learning, because these things are evolving, and it's important to sort of keep up with that. And the good news is that there are programs that have technical assistance and are here to help. So with that, I will end my slides and open it up to any further questions.
All right, thank you again so much, Nick. We've got a few questions here. Down at the bottom, we've got what is the prescriptive requirement for storage that you mentioned? I think it's just a little clarifying question there.
It is in the energy code, and I don't have it memorized, nor would I think would it be a good idea for me to try to capture it here live. Abigail, if you follow up with an email to either Ian or me, we can send you some resources and point you in the right direction for the storage requirements. Or I'm not sure if it was Abigail, maybe I misread the name, but whoever it was, if you could shoot an email to either Ian or myself, we can point you toward resources about the storage requirements and code.
Yeah, that one was anonymous, but
Okay.
Abigail does ask, and I think you may have covered this already, but is it important to be aware of sound and vibration transfer for HVAC heat pumps, outdoor unit, or mini split?
Yeah, absolutely. Sound and vibration transfer from outdoor equipment is very important to keep in mind. I would say uh, the it's mostly a concern in retrofit because you don't have as many options with in terms of where to put stuff, right? Like you have an existing site, and so it's like, where do we put it? We've dealt with that on a few existing sites. Like maybe the roof doesn't have the structural capacity to hold a heat pump water heating plant, and so you can't put it on the roof. And so where do you put, can you put it next to the building? Like that's right next to some apartments. Like that's too loud. It gets to be very tricky. So I would say sound is more of a challenge in existing building retrofits than it necessarily is um, in new construction. New construction, you just have to plan for it and it's fine.
Well, thank you. I got a question here from Krista Swan. Do you have any cost analysis available that compares all electric to what was a combo of gas electric and also incorporates solar generation?
I don't personally, but I guess a question I would have is that relevant? Because can you even legally build with gas in your jurisdiction anymore?
Yeah,
If you're building in LA, you can't. You're not even allowed to build with gas anymore, right?
yeah.
Ian might. I'm not sure.
I know we do have a chart for the build program that kind of compares the various measures.
Yeah,
What included in.
there was cost effectiveness analysis done for a number of reach codes that were passed over the last few years, comparing all electric and mixed fuel. But the reality is that the air quality manage the California Air Resources Board and the both South Coast and Bay Area air quality management districts are moving toward banning the sale of gas equipment basically by 2030. So in 7 years, you're not even going to be able to buy gas equipment, just period. And so if you put gas equipment into a building now, you are installing stranded assets that you're not going to be able to use. Like if your equipment fails, you won't be able to buy a replacement and you're going to have to electrify that building. And so like why do that? Why sort of dig yourself that hole? Like go ahead and build the building the way it's going to have to be eventually anyway. Even if you are legally still allowed to build with gas, um, you may as well just sort of move on from fossil fuels.
Yeah, Tim does mention in the chat that with the right consultant team, all electric buildings are cost neutral or cost positive when compared to the mixed fuel building. That's from the perspective of a developer builder. And I do recall that that's something Tim discussed at our decarbonization summit in February. Plug
Yeah,
to check that out on the CHPC website.
yeah.
Uh, more stuff.
Tim, I see Tim has a question. Is the CEC doing anything to incentivize commercial heat pump dryers? Tim, I haven't heard anything. That's like a conversation that we occasionally have. It's like I feel like every 2 years it sort of bubbles up and there's a few emails exchanged and then nothing happens. So if it's been maybe a year since I've emailed anybody about it. So if you have any insight, feel free to and time to take that on. Feel free to shoot me an email and we can talk about it.
Hmm. We've got, I think,
Um, yeah, let me just take a look at some of these other questions.
yeah. Let's see.
Yeah, there are a couple of questions that I'm not sure I fully understand. Um, there's a uh, question from Sophia about, yeah. I'm not sure. I don't know, Sophia, if you're still on and wanted to ask your question that you put in early on, I'd be happy to try to answer that. I'm not sure I understand the question.
Let's see, and then we've got this one last question about HVAC emissions. I don't know if you
Yeah,
have.
I'm not really sure what that one's asking either.
Well, it does about take us to our time. So thank you again to Nick.
We have I mean, we have a few more minutes. We're here till quarter after. If anybody has any other questions or Q&A.
Yeah, you can also always feel free to email us. I think we'll be happy to try to answer. Where on the CHP website are recordings of old webinars? See, the decarbonization summit. Let me see if I can get the link to that for you real quick.
Oh, there is one more question. Whether we'll ever see combined space and water heating. We do see it. It already exists. There are a few different solutions for it. As to like, it's just it can be done. The systems are, I don't know. You can do it. They're out there. You are putting all your eggs in one basket with that. So if the system goes down, you have no heating or cooling or hot water. So that's one challenge. They also tend to be a bit more sort of custom for each job, but they're out there, they're available. So you know, there are trainings from PG&E and elsewhere where folks from AEA go into much more detail about sort of heating and cooling systems, domestic hot water, heat pump water heating, sort of the more of the technical details. This was really intended to be a high level sort of overview for folks. So if people are interested in more of that, the nitty gritty details, feel free to sign up for one of those PG&E trainings.
Yeah, the PG&E trainings are pretty good. I did put the link to the decarbonization summit in the chat. It's chpc.net/decarb 2023. We've got some really good recordings there, a lot of good info, especially if you want to hear Tim talk more about kind of the cost effectiveness of all electric design. I would really recommend that. So we're about at time now. Deborah says thanks. Wonderful. So again, I'd like to thank our partners for this session. The programs that if you're interested in getting financing for some of these technologies, check out MCE, Build, Tech Clean California, SOMA, and LiveWhip. I also want to thank Scamp for helping to host this webinar on the back end, and as well as our sponsors, Wells Fargo Foundation and Energy Efficiency for All for financial support. Again, a reminder about the upcoming trainings. Next week, we have the IRA funding and participation pathways. That's going to be a real juicy topic, so be sure to sign up for that. September 20th, we have operations of all electric housing. So after you install all this wonderful equipment, how do you actually run it? On September 27th, we'll be looking at accelerating electrification with solar energy. That's increasingly common on developments. And then finally, on October 4th, financing and funding the electrification of new and existing affordable housing. So, you know, the $1 million question that everybody's always asking. So that's it. Thank you, everybody, for attending. I think we had a really good time today. Thank you again, Nick. Wonderful presentation, a lot of great information. And of course, the recording and slides will be sent out afterwards if you want to refer to anything that you saw today. So
Yeah, thanks everybody. Thanks for the great questions. Appreciate the participation.
Wonderful. So we're at 12:15 now. So I think go enjoy your lunch, everybody.